All right, so this is the rectangular form of a complex number, a plus bi. If I draw it, we're going to call this r. This is your modulus that we were just finding, the absolute value of a plus bi. Polar form, not a polar coordinate, okay? Polar coordinate is different. That's an ordered pair that has r and theta. This is polar form of a complex number, okay? So if you look at this, we have some argument, theta. The cosine of theta is a over r. So if I multiply by r, a is equal to the r times the cosine of theta. So I can replace a with r cosine theta. The sine of theta is b over r. So I can multiply by r, and b would be equal to r times the sine of theta. So I can replace b with r times the sine of theta. These two terms both have an r in common, so I can factor it out. Your textbook writes it out like this every single time. Well, the polar form of a complex number is the same every single time. Cosine of theta plus I sine of theta. There is an abbreviation for this. I think they pointed out somewhere in one of the side bubbles. They say, oh yeah, you can do this. But they do not write it out in the back of the book at all. They write this whole thing out every single time. Well, if you're writing this out over and over and over again, it can get kind of lengthy. So there is an abbreviation. This is an accepted mathematical abbreviation. So when you are doing your homework, you can write out this. It's called Anslysis theta, and that's how it's pronounced, okay? It means the same thing as this. So when you're checking your answers in the back of the book, if you have this, I'm totally okay with that. But otherwise, the back of the book writes the whole thing out. They're very formal with this. Again, there is absolutely nothing wrong with this. Some textbooks use this. Your textbook does not. But it's a lot of writing that it's going to save you if you use the abbreviated form. Okay? So again, r is called our modulus, and it's the absolute value of that complex number, or the square root of a squared plus b squared. A is equal to r cosine of theta, and b is equal to r sine of theta. Theta is called the argument. We've used that word before. So remember, inverse tangent, if I'm trying to find that argument, if I do inverse tangent of b over a, it's going to give me, no matter where theta is, it's going to give me an angle between negative pi halves and pi halves, okay? That is the range of inverse tangent. So if your a is positive, it means that your argument is either going to be in angles 1 and 4, and whatever you get for theta will be accurate. Now, if it's in quadrant 4 and you want a positive argument, you have to add 360 to it to get that angle, okay? But if a is negative, and it doesn't matter if b is positive or negative, you're going to be in quadrants 2 and 3, okay? So if I'm in quadrant 2, a plus bi is up here, and I do inverse tangent of b over a, it's going to give me a negative angle here. So I have to add 180 degrees to that, okay? If a is negative and b is negative, it's going to give me an argument here in quadrant 1 because tangent is positive in quadrant 3. So I still have to add 180 to that, okay? Theta is not unique, but is usually given as negative 2 pi to 2 pi. So we are taking these numbers in rectangular form and we are converting them to polar form. So polar form, we need two things. We need the modulus and the argument, okay? So you're going to have some that are nice answers, and you're going to have some that are not nice answers, okay? So for example, this, if you can already recognize this, is going to have a reference angle of 45 degrees, So negative 2 minus 2i, this is a negative 2 and this is a negative 2. That means that this is an isosceles right triangle. So this is 2 squareds of 2. And again, you can do a squared plus b squared equals c squared, but that's going to be my modulus. This is going to be 45 degrees. And so this is a situation where this is in quadrant 3. So I have to add 180 degrees to that. If they do not specify, everything is typically in radians, okay? Which is right here. So 45 degrees, not acceptable. We want to use 5 pi fourths. This is pi fourths plus pi would be 5 pi fourths, okay? And that's why we're adding pi right here. So rectangular form, polar form, my r is 2 squareds of 2. And then I would have cosine of 5 pi fourths plus I sine of 5 pi fourths. Or abbreviated version is 2 squareds of 2 cis 5 pi fourths. Rectangular form, polar form, not a polar coordinate, polar form. Okay. If they tell you to round in the book, you can round if you need to. But there are going to be some that are exact. There are going to be some that are not exact. Okay. And that's something that you can figure out. Negative 6 plus 8i. If you are already recognizing, this is another 3, 4, 5 triangle. This is a Pythagorean triple, okay? And so this is going to be 10. If you needed to find your modulus, you can do the square root of a squared plus b squared. The square root of 36 plus 64, square root of 100 is 10, okay? And then we need this angle right here. Well, 3, 4, 5 triangles do not have nice angles. So I'm going to have to use my calculator. So I'm going to have to do the inverse tangent of 8 over a negative 6, okay? I need to make sure that my calculator is in radian mode, and I don't think it is. Okay, we're good. So if I do the inverse tangent of 8 over negative 6, it gives me a negative 0.9. So I am going to, because I need this to be in quadrant 2, I have to add pi to that. And this is not nice. There's nothing we can do. The best that we can do is a decimal approximation. Most of your homework, when it's not a nice number, like the last one, when it's not 5 pi fourths, I think they have you round into the nearest hundredth. So in polar form, this one's going to be 10 cis 2.21. And again, I did inverse tangent of 8 over negative 6, but it's in quadrant 2, so I had to add pi to that. This is for my argument, which is 2.21, okay? And you can check your answer on these. So you can plug in 10 parentheses cosine of 2.21 plus I sine of 2.21, and you should get a negative 6.8i.